Hello and welcome to a Unit 1 and 2 review for Algebra 1. We're going to basically be reviewing solving equations and graphing equations and the things that kind of come along with that. So we have our first set of instructions here, say on 1 through 12, solve each equation. So I'm going to use the properties of equality, which are where you can do the same thing on each side of your equation. And so like I can divide both sides by 2 here to get rid of that 2. So x equals 5 would be our answer. I can always check this if I want to. If I'm on a test especially, that's a good idea. And say, okay, is it true that 2 times 5 equals 10? It is, so that means that x equals 5 really is my answer. Then I can just carry on with this in a similar way. So x plus 4 equals negative 11. I need to do the opposite of plus 4, so I need to minus 4 from both sides and get x equals negative 11 plus negative 4 is negative 15. Again, I'm probably not going to remember to do this for all of them, nor do I want to do this for all of them, but we can check. Negative 15 plus 4 does give us negative 11, so that would be our answer. Number 3. Now we've got two numbers on the same side as x, so we always keep the number that's being multiplied with x or divided with x for last. We move the things that are kind of farther away from x first, and so that would mean this negative 6 needs to get added over first so that we get negative 4x equals 20, and then we divide by the negative 4. So x equals negative 5. That negative looks weird. No, the 5 looks weird. Something looks weird. X equals negative 5. For this one where we've got division, and I think this is the only one that I didn't use x on, and I have n instead, so whoopsie, we would need to move the 2 first, so that means subtracting 2 over. And then this is just an easy thing to, I guess, kind of freak out about. What do I do with the 3 that's on bottom? I do the opposite, which is multiply by 3, because that would be like 3 over 1. The 3 on top and 3 on bottom cancel. So n equals 3 times 3, which is 9. Especially on one like this, if you're not sure in the process of what you're doing that you're right, double checking is helpful, because 9 divided by 3 is 3, and 3 plus 2 is 5. So, way to go us. Let's see, 2x plus 6 equals x plus 12. We need to get our x's on one side and our numbers on the other. So it doesn't really matter which direction you go here. I like to move it so it's positive, if possible. So that means subtracting x over. On the same step or on a separate step, you can subtract the number over to the other side as well. So 2x minus x is x, and 12 minus 6 is 6, so our answer is x equals 6. Now when we plug this in to check, you do have to make sure that you plug it in on both sides. So 2 times 6 is 12, 12 plus 6 is 18, 6 plus 12 is 18, so we got it, x equals 6. On 6, negative 4x plus 9, negative 8x plus 5. So I would recommend adding 8x to both sides, or adding 4x to both sides. It doesn't matter which one of those you do, because we should end up with the same answer, but you want to move the number the opposite way that you did the x. So since I moved the 8x over to the left, I'm going to subtract 9 over to the right. We don't want, for linear equations like these, we don't want them to, we're not trying to get everything on the same side. We're trying to get the x's on one side and all the numbers on the other. 5 minus 9 is negative 4, so I'm going to divide by 4 and get x equals negative 1. You know, if I was smart, I would check all of my answers, because otherwise it might turn out that you would find the error while watching the video. And then I'd have to be like, oh rats, it's not like I can change the video. Or is it worth it to change the video? Okay, so that's -1. Okay, just double checking. Now we've got multi-step equations, and once we start seeing these problems that have parentheses, this is where we should also be extra on the lookout for getting all real numbers or no solution, one of those special cases. Remember that happens when you end up when in the course of solving the equation, you cancel out both variables instead of just one. So that is going to happen to us at some point here, so that we see what it looks like. 3 times -2x is -6x. 3 times -9 is -27. And that's going to equal this 3x minus 45. So then I'm going to add 6x to both sides. And add 45 to both sides. Well, that's kind of a large number. 45 minus 27 is 18. 3x plus 6x is 9x. I'm going to divide both sides by 9 and get 2. So there's some order of operations here. -4 minus 9 is -13 times 3 is -39. This is 6 minus 45, which is also -39, so x equals 2 is correct. Okay, we got 2 to distribute here on this one. I'm going to change colors. 20x minus 20 equals 6x plus 6 minus 26. So we want to put these numbers together like normal. 6 minus 26 is -20. Oh, this is interesting. I'm going to subtract 6 from both sides and get 14x. I'm going to add 20 to both sides, which cancels. Now here's the deal. That didn't cancel out our 14x. It just canceled out the other number. So that means that there's 0 on that side. And so if 14x equals 0, then x has to be 0, because 0 divided by anything is 0. 0 on bottom, remember, is bad, but 0 on top is fine. So we get x equals 0, and then we'll check our answer and make sure we're right. So that's 0, then that's 4, so that's -20, that's 0 plus 3, so that's 6 minus 26 is -20. So we are correct. Let's see. Let's distribute here. We get 10x plus 15, and then a plus 4. Then here we get 10x and plus 30, and then minus 7. So we get 10x plus 19 and 10x plus 23. So if we might realize right now what's going on, or it may be that we decide to go ahead and subtract the 10x from both sides, and then we realize what's going on. But at some point along the way here, you should be like, wait, this doesn't work, because 10x plus 19 can't equal 10x plus 23. You can't have 10 times a number plus something and that equal 10 times a number plus something different. Those would have to be the same somethings. And in other words, 19 and 23 are not equal to each other. That's why this doesn't work. So whenever this happens, our variable went away. What we get is a not true statement. We say the answer is no solution. And you can't really like plug no solution back in. You'd basically just want to double check that everything went right. Your big clue for it being special cases is seeing that there's same x's on each side, like 10x and 10x or 5x and 5x, that it's the same on both sides once all your x's on either side are added together if needed. So there we go. 10. Let's have a color change here. Let's do 3 times 4x is 12x. 3 times negative 7 is negative 21. Gonna add 5. And then distribute this 2. So 12x and 12x, that's our big signal that this is a special case, but this time we get 12x minus 16 equals 12x minus 16. What that means is that literally we could put in any number we wanted to and have this work. You can take it a step further if you want to and say I'm going to minus 12x on both sides and get negative 16 equals negative 16. And then that means, okay, since those are true, negative 16 does equal negative 16. This is our special case of all real numbers. So wherever it was on this that you came to that conclusion, I think is fine. I'd prefer you not just look at it and say it's all real numbers, because I think that showing work is helpful. But if you get to this point, even actually on this step, if you're like, oh, I see what's happening here, then go for it. It's all real numbers. Okay, on 11, we have some fractions here. And so we have a strategy for dealing with fractions in equations. That strategy is get a common denominator. So first, actually, let's put this over 1 so we don't forget about it. And then we look at 2, 4, 8, and 1 and say, what can I make all of these end up as for a denominator? The answer to that is 8. And so then we go through and get common denominators. So this first fraction, you need to multiply by 4. The second one, we need to multiply by 2 over 2. This one is already has 8 on bottom. And then this last one needs 8 on bottom. So we times by 8. So that's going to give us 4 over 8x. And then 6 over 8. And then 7 over 8. And then 24 over 8, minus 24 over 8. The reason we did this is there's this really cool thing where if all the denominators are the same, we can just completely get rid of the denominators, because it's essentially making them all be on even footing, I guess you could say. Why we can do it, may not be as important as the fact that we can do it, but I do have a video where I think I talked about this if you wanted to go back and check it out. And just in general, this is all this review is a part of some curriculum I've made for Algebra 1 that you are absolutely welcome to check out. Link in the description to head over to my website and do that. You know how it is, shameless plug. All right, so that's 30 equals 3x. So divide by 3, x equals 10. Now, it's even more unpleasant to check this because we've got fractions, but it's probably that much more important if we actually want to make sure we get this right. A half times 10 is 5. So that gives us 5 3/4. 7/8 times 10 is, we'd cancel out a 2 and a 2, get 35 over 4 minus 3, which would be 12 over 4. This would be 23 over 4, which is the same as 5 3/4. So x equals 10 is right. On decimals, our trick is a little bit different, but kind of the same. We multiply all of these by some multiple of 10 that will actually get rid of all of our decimals. So 10 or 100 or 1,000, just depending on how many decimal places there are. With decimals, it's a little bit less of a necessary thing to get rid of the decimals. Like, I think we're better at keeping track of if you wanted to just add 0.15 over to the right side. I think you're probably very capable of doing that. It's really when we get to the point where we're dividing by a decimal that it becomes really unpleasant. So I am going to multiply just everything by 100, and it just moves the decimal to the right 2 places for everything. It just makes it seem nicer to not have decimals to deal with. So then we're going to subtract 51x and add 15. So that's 24x, and 57 plus 15 is 72. I almost put the 2 first, that's why that 7 looked weird. 72 divide by 24, and x equals 3. So it is much more likely that on a problem where we start with fractions or decimals that we would get, oh, I do not want to check this, that we would get a fraction or decimal answer. So do keep that in mind. Okay, 0.75 times 3 is 2.25. Minus 0.15 is 2.10. This is 3, 5, 1. Yep, they are both 210. So x equals 3 is the answer. We are 12 for 12. Okay, now to graphing. So graph and label the following points. We've got 4 different points to label here. So 3, 5 would be A. Remember that it's x comma y, so you go left or right first, up or down second, right, so this is x, this is y, right is positive, which I guess is labeled here, and up is positive, and then left is negative, and down is negative. So 3, 5, negative 6, negative 2 is B, 0, 8, so don't go left or right, just go up 8 for C, 4, negative 1, is here for D. What is the slope of the following line? Remember, slope is rise over run. So pick out 2 of these points that they gave us and count out the rise and the run. So kind of think of it like streets, right? If there's not a diagonal road getting you where you need to go, you'd have to take blocks. So we'd go down 1, 2, 3, 4. So that's negative 4. We'd go right 1, 2, 3, and get negative 4 over 3, which is negative 4/3. No matter which 2 points you pick, as long as you're picking either, you should pick the ones that have dots on them because I gave you that on purpose to make it easier, but any points that are on grid lines will work, and then simplify if needed. So yeah. Number 15, what is the slope of the line that goes through the points negative 2, 3, and 4, negative 7? There is a formula that we can use for this, y2 minus y1 over x2 minus x1. We could have used that on the last one, but because visually slope is essentially how much it's going one direction and then another, it can be really easy just to count it. So whenever we use the formula, we're saying that we have 1 point, x1 and y1, and a second point, x2 and y2. That's what the little numbers are for, to tell us the difference between the first point and the second point. Now we do need to be careful here, because as we do this, y2 minus y1, okay, that's -7 minus 3, which is -10. X2 is 4 minus -2. So 4 minus -2 is really 4 plus 2, and that's going to give us 6. And then I would simplify this by 2 and get -5/3. A little bit tougher to check these problems, other than just to like go back after you've maybe finished the review or test or whatever it is, and just think about it again. That might be your best option. So what can you tell me about linear equations? Hopefully you can tell me a lot, like linear equations make lines. That would be something. Linear equations have variables to the first power, as opposed to the second or third or fourth or fifth or whatever. Linear equations are fun. You know, these are just some options. Linear equations, you know, have slope. I don't know. That's kind of the things that I'm thinking of. I'm sure you can think of other things as well. 17. We have a table of values that we're going to use. This is not actually going to give us a line. It's not a linear equation. But it's my hope that it's pretty straightforward for you. What we want to do is we want to plug in each of these numbers that I've given you, -2, -1, 0, 1, and 2, in for the absolute value one at a time. So we do -2 in the absolute value plus 1. We absolute value first, which switches this to 2, and we add 1 and get 3. So that's that answer. And then we just keep going and do it for the rest of these. So -1 absolute value is +1. +1 plus 1 is 2. Absolute value of 0 is 0 plus 1 is 1. Absolute value of 1 is 1 plus 1 is 2. And absolute value of 2 plus 1 is 3. And so at 0, we're at 1, and then we've got this V-shaped. On the lesson that I did on graphing using a table of values, I gave a few different kinds of functions that are relatively straightforward, that you end up graphing more in Algebra 2 and pre-calculus. I didn't have to make these the lines go all the way to the edge, but I thought it was fun. But definitely take a look at that lesson, look back at that lesson as a part of your studying, just to remind you kind of what options there are. Like, I'm not going to give you something you haven't ever seen before, but anything that was on there is technically fair game. So keep that in mind. Let's graph using slope-intercept form. So slope-intercept form is y equals mx plus b, where m is our slope, which is rise over run, so that's this right here, and b is our y-intercept. So we begin with b, so we put a dot at -3, and then we use our slope to rise and run. Since it's a +1/2, we're going to go up 1 and right 2, or down 1 and left 2. They either both have to be positive directions or both have to be negative directions in order for for us to get a positive fraction. Wow. And then we just draw our line both directions, and there's our answer. So you may notice that after these 3 points I drew, my line gets a little bit wiggly. Yours might too, and that's fine. I'm going to be focused on, did you put the y-intercept in the right spot? Did you count out the right slope? And don't get carried away making it look terrible, please, but otherwise it should be good. Let's see. Graph using slope-intercept form. This is y equals 4x. There is no intercept here. That means that we would have an intercept of 0, And our slope, which is not a fraction, we turn into a fraction by putting it over 1. So we rise 4 and run 1. And here is our slope. And then here on 20, we have a y-intercept of 5. Our slope is negative this time. So for negative slopes, you want to either think of it as negative 2 over 3 or positive 2 over negative 3, because having a negative in front of a fraction means one or other are negative, but not both, because negative slopes are supposed to go down and to the right, and if you actually make them both negative, you'll end up going down and to the left, and that's not going to work out okay for you. So make sure you're paying attention to that as you study. There we go. Now, there's a couple other situations we could have here. Graph the following equation using intercepts. So that's where you put in a 0 where x is and a 0 where where y is and solve. It's also called the cover-up method. So you can cover up this part and solve by dividing both sides by 3. And that tells you that the x-intercept is 4. And then we just kind of start over and say, okay, now let me cover up the 3x. So divide both sides by 4, and we get y equals 3. So these are both intercepts, so they go on the x and y axis. X equals 4, y equals 3, and then we do the line between them. This equation was not in slope-intercept form, so our options were either to graph using intercepts, which is what it told us to do, or to solve for y, which is what 22 tells us to do. So on 22, we are wanting to get y by itself, so we're going to add 2x to both sides. It doesn't actually add, though. We write them next to each other, 2x plus 15. Then we divide both sides by 5, which divides everything by 5, and gives us something that looks a whole lot like slope-intercept form, because it is. This would be a y-intercept of 3 and a slope of 2/5, so up 2 and right 5, down to left 5, and here's our line. And last, we have x equals 4 and y equals 2. It says graph however you want to, because basically one of these is a vertical line, one of these is a horizontal line, and you've got to, typically people either memorize this really easily or have a hard time with it. When you're saying x equals 4, you're saying that the only thing that I'm allowed to put here is 4, but that y can be whatever it wants to be. Another way of thinking of that is x is 4, so I go to 4 on the x-axis, and then I draw a line not the same direction as the x-axis, because that doesn't make sense. I'm going to draw a line opposite of the x-axis, and so it is a vertical line. And you can see how that matches up with our points over here. We've got 4, 1, 4, 2, 4, 3. All of our x values for this line have to be 4. That's what x equals 4 means. For 24, we've got y equals 2. So we can think the same thing with the table of values, that y has to be 2 the whole time, but x can be whatever it wants. We can think about putting a dot at 2 on the y-axis because it's y equals 2, and then just drawing a horizontal line. I was trying to remember a really lame mnemonic device that I've heard before. Oivux. That sounds terrible. Vertical lines are undefined and our x equals a number. Horizontal lines have a slope of 0 and our y equals. So 2 random words that sound funny. Hoi and vux might help you remember this situation. Maybe. So horizontal lines are y equals, vertical lines are x equals. And that's basically it. That's our review for solving and graphing linear equations. Hey Hey, thanks so much for watching. Hope you had a good time. Hope you are doing a good job of studying and being successful in your math class. Please feel free to like, subscribe, all that jazz, and I'll see you in the next lesson.